Good evening, children. Today we are going to start D and F block for JEE Mains in Advance. So let us see what are the questions that we have today. Okay, so first question on your screen, everyone needs to pause and try. Okay, children. So let us see what is given to us. It's an assertion reasoning type of question. Yes, it is an assertion reasoning type of question. And it is said that in aqueous solution, Cr2 plus is reducing while Mn3 plus is oxidizing. So before looking at assertion and reason, so let's see, when we talk about this reducing, we must know that it will undergo oxidation. If it is oxidizing, it will undergo reduction. So before that, we need to write down the ground state electronic configuration. For chromium, it is argon 18, 4s1, 3d5. Yes? Okay. Now, if we look at Mn3 plus, if we look at Mn, it is argon 18, 4s2, 3d5. Right? Okay. Now, if we see, children, if we see here, what is going to be the answer here then? So it is telling that in aqueous solution, Cr2 plus is reducing while Mn3 plus is oxidizing in nature. It is telling that Mn3 plus is oxidizing in nature. Extra stability of half filled is observed than in completely filled electronic configuration. So here, now if we see that, if we look at Cr2 plus, if we look at Cr2 plus, then what is going to be in case of Cr2 plus, children? It is going to be 4s1, 3d4. Yes, sorry, this is going to be 3d4. This is going to be 3d4. Now, and in case of Mn3 plus, now if it is Mn3 plus, then if you see, children, what is going to be in case of Mn3 plus? This is going to be 4s2, 3d5. If you remove 3 electrons from here, then this is going to be 3d4. So it will try to become, it will try to become what, children? 3d5 by gaining one more electron, because those electronic states are more stable. Why it is undergoing, why it is going to become 3d5? How it is going to become 3d5? It is going to become 3d5 by what? By gaining one more electron. So that's why this statement is correct. And why are they gaining or losing? Because we know that half filled configuration is more stable as compared to the incompletely filled electronic configuration. That's why your both A and R are true, whereas R is the correct explanation of E, right? Okay. Next question on your screen, children. Okay, children. So here, what is being asked to us? It is asked about orange color and purple color. So you know that color is because of unpaired electrons. Color is because of unpaired electrons, but there are some things written: charge transfer, another is DD transition. So if there is unpaired electron, only then we can have your what? DD transition, right? So let us check if this DD transition option is available for any one of them. Then we'll discuss the charge transfer, right? So if you see the electronic configuration and you find out the oxidation state here, we have to find out for the chromium and manganese here, right? So for K2Cr2O7, we have potassium as 2. This is 2x minus 14 is equal to 0, which implies minus 12 plus 2x equals to 0, which implies 2x equals to 12 or x equals to plus 6, right? So in case of chromium, it is plus 6, right? Talking about the other one, this is plus 1, this is x, this is minus 8 equals to 0, which implies x equals to plus 7. So in case of manganese, children, it is plus 7. Okay, let's solve these. So for chromium, it is plus 6. Talking about manganese, it's plus 7. Manganese is plus 7, right? So if we see the electronic configuration, this is argon. Now, if we see, children, plus 6 means you have to remove 6 electrons. So here you remove 5 and here you remove. So plus 6 means this is just argon 18. So all filled, right? Okay. Then here 5 and 2. So 7, all 7 electrons are removed. So all filled. Yes, this is all filled. Yes. Okay. So as there are no unpaired electrons, so as there are no unpaired electrons, so can I say that DD transition, DD transition, DD transition not possible at all? Yes, there is one option left over, that is charge transfer. So charge transfer is going to be your correct answer. So why is the color orange and purple? It is because of charge transfer and not because of DD transition. Because in case of DD transition, we would require unpaired electron and there are no unpaired electrons which can undergo DD transition here, right? Okay. Next question on your screen. Okay, children. So here it is talking about diamagnetic. Diamagnetic means all electrons are paired, right? And for this, you have to look at their electronic configuration. You have to look at their electronic configuration. So let us look at their electronic configuration. So here it is for cerium and lanthanum. Yeah. If you look at the electronic configuration of cerium, you have 4f15, 4f1. Sorry. Yeah. And you have 5d1, 6s2. Right? As you can see here. Now if it is cerium 4 plus, you have to remove 4. So 1 from here, 1 from here, 2 from here. So 4 electrons are removed. Then cerium has only the configuration of xenon. Right? And obviously here all the electrons are paired. Similarly, talking about lanthanum. This is the electronic configuration of lanthanum. As you can see, 4f0, 5d1, 6s2. Now, if you were to remove 3 electrons, so d, s2, so all the 3 electrons are removed. So again, this is again diamagnetic. Yes. So what happens, children, if this is diamagnetic, then we see that these two are present only in one option, that is your A. option. So as you can see further also, you are going to get questions from electronic configuration. इस बार जो question आया है 2024 का ही question है ये, जो सारा हम discuss करने वाले हैं 2023 and 24 questions. You'll see that at least 1 or 2 questions are from electronic configuration. At least 1 or 2 questions are from electronic configuration. So you have to do these electronic configurations thoroughly, right? Okay. Let us go to the next question, children. Next question on your screen and try. Okay, children. So it is asking that certain things are given to us about zinc, cadmium and mercury, and you have to find out that which of the following statements are correct. It is talking about the high enthalpy of atomization. When we know that about these three elements, right? Your zinc, cadmium and mercury, their outermost shell is completely filled. Okay? And we know that when it is completely filled, the enthalpy of atomization is low. Right? When it is completely filled, the enthalpy of atomization is low. That's why this statement is wrong. Okay? Then, zinc and cadmium, they do not show variable oxidation state, whereas mercury shows +1 and +2 oxidation state. This statement is correct. Yes, we haven't seen zinc showing any oxidation state. Okay? Mostly they are in +2 oxidation state. Cadmium and Zn2+, they're in this state. Right? Yes. But mercury shows +1 and +2 oxidation state. So this statement is correct. So wherever B is not present, you can cancel that. Right? Okay. So we have to check between C and D now. Now, the compounds of zinc, cadmium, mercury are paramagnetic in nature. Now this is absolutely wrong. Why it is absolutely wrong? Because we know that, children, that it is talking about paramagnetic, and paramagnetic means at least one unpaired electron. At least one unpaired electron. Do we have unpaired electrons? No. We know that these three elements, okay, they're controversial elements and they have all their shells filled, completely filled, right? And they were initially not regarded as d block elements just because they're the end elements. They have been taken into consideration, right? So they have completely filled. So this is wrong because they are diamagnetic. They are called as soft metals, okay, because as they're completely filled, metallic interaction is low, and the inter electronic attraction is low, and that's why they are soft metals, right? Okay, why are they soft metals, children? Talking about soft metals, we know that the higher the number of unpaired electrons, so inter-electronic, your attraction or interaction is very high, and it is more, metal is more hard, right? And as they have all the electrons which are paired, that's why they are soft metals. So answer is B and D, right? Okay, so B and D only is going to be the answer. Is this clear, children? Yeah, things are becoming clear. Okay, let us move on to the next question. Yeah, so next question on your screen, everyone, try. Because just now we have completed coordination chemistry. So coordination chemistry is linked to D block elements, right? Okay, so this question is kind of both related to coordination chemistry and D block element. Yeah, so this question was asked in 2024. The first few questions are previous year questions which are asked in the year 2024. So this was also asked in 2024. So first thing we are going to see the oxidation state, because if we found out one oxidation state is 7, then we have to eliminate the other options and that is going to be our answer. So we'll find out. So K2 means 2 plus Mn is X. This is minus 8 equals to 0, right? So here we are getting that X equals to plus 6. So obviously this is not going to be the answer. This part is eliminated. Okay. Now this will be your counter ion. So potassium is there everywhere. Okay. All right. Then this is manganate. This part is also correct. This part is also, only you have to identify what do you call it as O4. Yes. O4 tetra is there everywhere. Now at one place it is given as tetroxido and oxo, right? And one more place it is given to you as manganese. Are we going to write manganese? We are not going to write manganese. Why are we not going to write manganese? Because we know that the counter ion is a plus, right? The counter ion is K, which is, it is a cation, right? So whatever the complex is remaining, the MnO4 minus, that is your what, children? The MnO4 2 minus, that is your what? Anion. This is your anionic complex. And whenever you are having the anionic complex, the name of the central metal atom ends with ATE. The name of the central metal atom ends with ATE. So this is going to get cancelled. Yes. So now here manganate is there, here manganate. One is, this is oxo and this is oxido. So which one is the correct answer? When only O is there, we call it as oxido, right? We call it as oxido, and A is going to be your correct answer. A is going to be your correct answer. So did you understand how we did it? So first thing, that 7 is not there, so we eliminated this. Yeah. Then we know that it is not manganese because an ionic complex, so we eliminated this. And out of this, it is very easy. One is oxido and another is oxo. This is not oxo, right? Oxo is your carbonyl, something written like this. Yeah. This is your prefix for organic chemistry. If you are having a what group? Aldehyde is there and one more is your ketone is there. So for ketone you use the prefix oxo, right? So this is not oxo here. So oxo is definitely wrong. Yes. Okay. Moving on to the next question, children. Next question on your screen, and it's a direct question from NCERT. Anyone who has read NCERT is definitely going to make it correct. Yes. So it's a direct important question from NCERT. So try it, children. Okay, children. So what is the question here? It is saying that KMNO4, if you are heating it at 513 Kelvin, so what is it going to give you along with O2, right? That is our question, and it's a direct question whether K2MnO4, KMnO4 when it decomposes, it gives K2MnO4 and MnO2, right? It gives you K2MnO4 and manganese dioxide. So MnO2 is not there anywhere. Okay, only these two options, and here K2MnO4 is there, and that is going to be your answer, which is option number C. So option C is going to be your correct answer, and this was directly from NCERT. Yeah. So again, this was asked in the year 2024. So some direct questions are being asked. So this is a direct hint at you that you refer NCERT and its questions. This one, children. Okay, children. Let us read what is given in the question. Choose the correct option of having all the elements having D10 configuration. Having D10 configuration, right? So this question, the one who has a basic common sense is going to take only 10 seconds, right? Although I'm going to solve it and show you entirely, but you see, children, there is those who know the electronic configuration from 21 to 30. It's going to be very easy for you. For example, nickel, right? Nickel. Okay, so if you talk about nickel, we know that it is 28, right? Fe, co, ni. So this is 26, 27, 28. So this is argon 18, 4s2, 3d8. So we see that this is not d10, this is d8, right? And nickel is almost everywhere. In all these three options, there is nickel. Okay, so you know that this is not going to be the answer, and here nickel is not. This is going to be your answer. Yes, that was a way of identifying. There's one more way I'll tell you. Even if you don't know for nickel, let us look for chromium, right? You know for chromium because chromium is very frequently used, right? So chromium, if we look for chromium, let us see. Chromium is 24, it's given to us like this. So chromium, we know that it is argon 4s1 3d5. We know that this is half filled. So again, chromium was here, so this gets cancelled. Chromium was here, this gets cancelled. Chromium was here, this gets cancelled. So that was another way of identifying. There's one more way of identifying. Like if you see Fe, Fe, yes, you took one element, and if you know the electronic configuration, you are going to pass, right? So for Fe, Fe is 26. So argon, this is 4s2 3d6. This is 4s2 3d6, right? So if it is 4s2 3d6, this is not d10. So your Fe is here, Fe is here, Fe is here. So that is also going to get cancelled. So even if you knew one of the element which doesn't have a d10 configuration, your answer was going to be solved, right? Okay, so obviously your answer is going to be B, which is copper. Just a minute. Okay, which is copper, zinc, cadmium, and Ag. Now let us look for these three then. Yes, now if we look at these three, as you can see here, children, we know that chromium is having D5. Yeah, so this is half filled, so this is not going to be the case. Now looking at copper, the exceptional one, which is 4s1 3d10. So this is having D10. Again, if you look at zinc, this is from D series, okay, D10, this is correct. So why I'm telling that you need to know something which doesn't have a fulfilled one is because sometimes what happens, children, we are so engrossed in learning the first D series that sometimes we forget to remember the electronic configuration, or somehow we forget the trick to know the electronic configuration of like cadmium or silver, right? So even if you knew any one of these of the first D series, if you know, you could eliminate it by using options. Although you should know anyhow for cadmium, mercury, silver, these are the common ones and you need to know them, right? So if we look at the electronic configuration for Ag, it is 5s1 4d10. So again d10 is here. For cadmium it is 5s2 4d10. So again d10 is here. So all these you are having d10. right? Okay, so this was again asked in 2024. So you see how many questions are being asked from electronic configurations, right? So you have to make it thorough for electronic configuration. Next question. Try this, everyone. Okay, children. So what is the question being asked to us here? Which of the following electronic configuration would be associated with highest magnetic moment? This was again in 2024. Yes. So highest magnetic moment. So we know that here when talking about the magnetic moment, we talk only about the spin only magnetic moment, right? Talking about the spin only magnetic moment, it has a symbol of mu, which has the formula root over of n into n plus 2, and it is represented by Bohr magneton. Yes, this is called as a Bohr magneton, where n, children, is the number of unpaired electrons. Number of unpaired electrons. So if we see here, children, you just have to know it is D7, right? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7. So here the number of unpaired electron is 3, right? So n equals to 3. So can I say that the one which has a higher number of unpaired electron is going to have the highest magnetic moment? So number of unpaired electrons is directly proportional to mu. So more is the number of unpaired electron, more is going to be the magnetic moment. So can I say here, children, this is also 3, this is also 3. So this is not possible. Yes, these two are not possible, because here also you have 3d3 and you have 3d3 means you will be having all the electrons unpaired only. 1, 2, 3. So here also 3 unpaired electrons. So this is not possible. 2 cannot be correct at once because this is a single choice answer, right? Then looking at the other one, this is 3d8. So this is 3d7. So obviously 3d8, for 3d8, okay, if you have 3d8, one more electron is going to be here. Yes, if 3d7 is having 3 unpaired electrons, so definitely 3d8 is going to have 2 unpaired electrons. If 3d7 is having 3 unpaired electrons, 3d6 is going to have 4 unpaired electrons. Yes or no, children? So if n equals to 4 here, then can I say that obviously this is going to have the highest magnetic moment. This is going to have the highest magnetic moment. You can see it by yourself here. So 1, 2, 3, 4, 5, 6. Now if you see here, this is 1, 2, 3, 4. So your n equals to 4 here. Your n equals to 4 here. So as your n equals to 4, it is the highest number of unpaired electrons. So as you have the highest number of unpaired electrons, so this the magnetic moment is going to be highest. Yes. So what is going to be the correct answer, children? Definitely option D is going to be your correct answer. Right. So what was the takeaway point from here, children? The takeaway point from here was that you have to know the formula of the magnetic moment, that is root over of n into n plus 2, and that the number of unpaired electron is directly proportional to the magnetic moment. Yes. Okay. Next question. Try, everyone. Okay, so let us read what is given in the question here, children. It is given to us that NaCl is there. It is reacting with concentrated H2SO4 and potassium dichromate, right? On reacting, it gives some reddish fumes of B, right? So it gives you B, which reacts with, this B reacts with NaOH to give yellow solution of C. So what happens, children, here? One thing that you need to know here, that if you have read the preparation of K2Cr2O7, then you are going to definitely know what this answer is. This is also again directly from your NCERT, the preparation of K2Cr2O7. In that page it is there which one is yellow color, which was in which color. So you can find out one from there, right? So now see, children, there's one thing that you need to know, even if you don't know the compound, okay? But you know that if you see here, you see the reaction here, okay? If you see the reaction here, this is NaCl, H2SO4 and K2Cr2O7. So when it reacts, what does it give you? It gives you this CrO2Cl2, right? CrO2Cl2. And this is going to be which color, children? Which color? It is going to give you reddish fumes. And we know that sodium is there, children. What is there? Sodium. Sodium can never give us red color. Okay, we know it from the flame test itself. The sodium itself, wherever there is sodium, there will be something related to yellow, white, something like that. It's not going to give you red color. It's not going to give you red color. Yes or no, children? So that's why we see that the CrO2Cl2, the CrO2Cl2, this is not your yellow color. This is not yellow color, right? Okay, so whenever the CrO, Na2CrO4 is given, this is going to be cancelled. Yes. Okay. Now yellow. Yellow is not going to be this, so this is going to be get cancelled. Yeah. Now Na2Cr2O7 and Na2CrO4. So if we see that Na2Cr2O7 is not yellow in color. Okay. So if you see the reaction here, children, you can see that we are getting CrO2Cl2 with NaHSO4, KHSO4 and H2O. Now when this reacts with NaOH, so here you are getting your yellow color. Here you are getting your yellow color. So now did you understand that you are going to get questions from preparations as well? Yes. So all the reactions are important. Just a minute. Okay. So which one is going to be your correct answer, children? Your correct answer is going to be A. So A is going to be your correct answer. Yes. Okay. Now next question on your screen. Okay, so I'll read the question. My image might be blurring out the question, right? So let me read it. What is given? So given below are two statements. So obviously this is assertion reasoning type question, and what is given here is telling that 5f electrons can participate in bonding to a far greater extent than 4f electron. This is being told here. The reason is that 5f orbitals are not as buried as 4f orbitals. Okay, so let us try to understand this, that where there is a case where 5f orbitals can participate to a far greater extent in case of instead of 4f. So this is the case in case of what, children? In case of actinoids. Yes or no, children? We know that we have actinoids and lanthanoids. Yes. We have actinoids and we have lanthanoids. So in case of lanthanoids, we know that gradually the 4F is getting filled. Yes, there is gradual filling of 4F. Now, in case of actinoids, there is gradual filling of 5F, right? So we can say that this can participate in bonding to a far greater extent as compared to 4F. Why is that so? Now we understood that 5F can participate in bonding as well because in actinoids this is getting filled up. The reason is that the 5F, they are not buried, not as buried. What does this buried means, children? Buried means it is what? What do you say for buried? Buried means it is not that much protected. It is not that much protected, right? So it is not that much protected means it is exposed to the outer environment. Yeah, it is not that much protected means it is exposed to the outer environment. So when it is exposed to the outer environment, then it is available for interaction. It is available for interaction. When it is available for interaction, then I can say that this 5F orbitals can participate in the bonding. This 5F orbitals can participate in the bonding in case of where, children? In case of actinoids. Yes. So can I say that the assertion is true? Yes, the assertion is true. Can I say the reason is true? The reason is also true. But can I say that A is the correct, R is the correct explanation of A? Yes, obviously. 5F electron is participating to a greater extent because it is not as buried as your 4F, right? Yes. So which one is going to be the correct answer, children? A is going to be your correct answer. That is, both A and R is true and R is the correct explanation of A. R is the correct explanation of A. Yes, children? Okay. Okay. Let us see what is given in the question. Which halogen is known to cause the reaction given below? And we'll see what is the reaction given to us here. The reaction that is given to us here is 2Cu2 plus 4x minus give rise to Cu2x2 plus x2. Right? Okay. Now children, the option is iodine, bromine, chlorine, all halogens. These are the options that are given to us. Now, if we want to form a compound of copper with halogen, if we are trying to form a compound, that compound is going to be formed where the bond between halogen and halogen can be broken easily. Can be broken easily, right? And as we know, when we go down the group, in case of halogen, so we have fluorine, chlorine, bromine, iodine. So this one, as we know, this is the largest. This is the largest. Yes. So as this is the largest, we have I bond I. We have what, children? We have I bond I. So as we have I bond I, we know that being largest, this bond is weak. As this is weak, this can be broken easily. But if you see in case of fluorine, in case of chlorine, in case of bromine, yeah, these both are stronger, right? stronger and cannot be broken that easily. This cannot be broken that easily, hence it is very difficult, right? So can I say that the answer here is going to be what, children? Only iodine. The answer going to be here is only iodine. And why is it going to be only iodine? Did you all understand, children? Because the bond breaking enthalpy is very less. Okay. Now again, one more question. Okay. So let us see what is given here, children. It is given in chromyl fluoride. The number of d electrons present in chromium are same as in. So what is the formula of chromyl chloride, children? This is the formula of chromyl fluoride, right? Okay, so if we want to find out the oxidation state here of chromium, you know that this is X. This is -2 into 2 plus 2 into -1 is equal to 0. So X minus 4 minus 2 is equal to 0. X minus 6 is equal to 0, which implies X equals to plus 6. Right? So we know from here that chromium has an oxidation state of plus 6. What is the oxidation state of chromium here? It is plus 6. Now, if we write down the electronic configuration here of chromium, now if I want to remove 6 electrons from here, one from here, from here, so it is going to have only argon 18, right? This is going to be the electronic configuration of chromium 6. So how many d electrons are present here, children? If we calculate the number of d electrons here is 0. Number of d electrons here is 0, right? So we have to find out something like that where the electronic configuration shows such a configuration where the d electrons are 0. So let me check if there is any answer, right? Easy one, children. Okay, so if we calculate, so we need that the number of d electrons. So let us calculate. For titanium, it is saying 22. It's given everything here. So argon 18, 4s2, 3d2, right? So if it is Ti3 plus, so 2 from here and 1 from here, so it is D1, 3D1 is remaining. So 1 electron is remaining, so this is not the answer. Fe is 26. So for Fe I write down. So it is plus 3. So 2 from here, 1 from here. So this is going to be 3D5. So 5 unpaired electrons, or 5 electrons here. Then vanadium. Vanadium is 23. Right? So if you remove 4 electrons from here, 2 from here, 2 from here, so 1 is remaining. So this is going to be 3D1. Yes or no? This is going to be 3D1. So if it is going to be 3D1, then what is remaining? Obviously manganese is going to be the answer, but still we are going to check. This is 27. Yes or no? Sorry, 25. So this is going to be 4s2 3d5. Yes. Now it is plus 7, so you have to remove 5 electrons from here. So 2 from here and 5 from here. Yes. Can I say 2 from here and 5 from here? So we know that here all the 7 electrons are removed. So this is 3d0. This is 3d0. And what were we asked for? We were asked for chromyl chloride. So CrO2Cl2. Here you get chromium is plus 6. And here you get for manganese. Yes. So this is going to be your correct answer. Yes or no, children? So manganese plus 7 is going to be your correct answer. Yes. Now, next question on your screen. Yes, so someone says B is the answer. Which one should I repeat? Okay, so chromyl chloride, see children, CrO2Cl2. Okay, first I'll explain this one. It is talking about Nessler's reagent. Okay, so this is talking about Nessler's reagent. So when you're talking about Nessler's reagent, if you know the formula is K2HgI4. The formula is K2HgI4 for Nessler's reagent, right? Okay, so this was asked in 2023. So if you know the formula, then exactly you are going to get your answer, right? You're going to get your answer. That is which one, children? If you see potassium is there, yes, potassium is there. If you see Hg is there, Hg is there. I is there, I is there. So N only is not there. Only N is not there, right? Okay. So if N is not there, then which one is going to be your answer, children? Your answer is going to be option B, right? Your answer is going to be option B. Now someone was asking to repeat the answer. So I'll explain again. So see here, children. CrO2Cl2, राइट? ये है क्रोमाइल क्लोराइड का फॉर्मूला. तो यहाँ पे तुम लोगों को बस फॉर्मूला जानना था. यहाँ पे क्रोमियम का एक्स है, हमें नहीं पता है. ऑक्सीजन का, एक ऑक्सीजन का चार्ज होता है -2, पर यहाँ पे 2 ऑक्सीजन है तो -2 × 2, 2 ऑक्सीजन है. एक क्लोरीन का चार्ज होता है -1, तो -1 यहाँ पे 2 क्लोरीन है. टोटल का चार्ज है 0. टोटल का चार्ज है 0, राइट? इफ द टोटल चार्ज इज 0, so this is going to be x - 4 - 2 बराबर का 0, यानी कि x - 6 बराबर 0, यानी कि x बराबर प्लस का 6. क्या है? x बराबर प्लस का 6. अगर ऐसा होता है तो यहाँ पे जो क्रोमियम है, यहाँ पे जो क्रोमियम है उसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या होता है? 4s1 3d5. 4s1 3d5. इफ इट इज 4s1 3d5, तो यहाँ से 1, यहाँ से 5, तो 6 इलेक्ट्रॉन यहाँ से ही निकल गए, राइट? तो क्रोमियम के पास कुछ भी डी इलेक्ट्रॉन नहीं है, यानी कि d0. क्या है यहाँ पे? d0. अगर हम यही चीज किसके लिए देखें, अगर हम मैंगनीज का +7 एक ऑप्शन में था हमारा, ठीक है? मैंगनीज का अगर हम लोग +7 देखते हैं और इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन अगर हम लोग देखते हैं, इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है बच्चा लोग? वी आर हैविंग आर्गन 18. सिर्फ मैंगनीज का अगर हम लोग देखें 4s2 3d5, यहाँ से अगर 7 इलेक्ट्रॉन हटाएंगे +7, तो यहाँ से 7 इलेक्ट्रॉन हटा देने से यहाँ से भी 3d0. इसीलिए जो करेक्ट आंसर हो गया वो था तुम्हारा जहाँ पे 3d0 था, राइट? ओके. Okay, so have you cleared JEE mains this time? What's your percentile this time? Okay, 97. Okay, so okay, there's a link in the description. Is there any link in the description where you can see? There is a registration link. There would be a number also in the website. So you can call on the website number that is given, and there you can like talk anything regarding the advanced thing. And also after this there will be a session for advanced maybe. Okay, so just talk once in that website. Okay, then we'll see what else can be done. Okay, okay, try this now. Try this question. Okay, let's see. So what's given here? यहाँ पे क्या दिया रखा है? यहाँ पे ये दे रखा है NiCO4 and FeCO5 have metals in zero oxidation state, right? तो जैसे कि हमको पता है कि इसका चार्ज जीरो होता है, इसका भी चार्ज जीरो होता है, राइट? सो वी हैव निकल CO4. ये कॉम्प्लेक्स में अगर हम लोग देखें तो इसका चार्ज क्या है? जीरो है, इसीलिए x प्लस जीरो टोटल का जीरो है, यानी कि x बराबर जीरो हो गया. उसी तरह FeCO5 है, ठीक है, तो यहाँ पे ये जीरो है, राइट? और दिस इज x, सो x प्लस जीरो इज अगेन जीरो, सो हियर योर x इज इक्वल्स टू जीरो. तो पहला स्टेटमेंट तो सही है. इन दिस कॉम्प्लेक्स द मेटल्स हैव zero oxidation state, right? So the first statement is correct. So the first statement is definitely correct. Yes, okay. दूसरा स्टेटमेंट, इसका रीजन ये बताया गया है, लो ऑक्सीडेशन स्टेट्स आर फाउंड इन अ कॉम्प्लेक्स दैट हैव पाई डोनर. दिस इज नॉट डोनर, राइट? यहाँ पे तुम लोग पूरे स्टेटमेंट को पढ़ते नहीं होता. यहाँ पे दिस इज पाई एक्सेप्टर, राइट? जैसे कि हमको पता है ये जो कार्बनिल होता है ये बैक बॉन्डिंग टाइप का बॉन्डिंग दिखाता है, विच इज अदरवाइज नोन एज अ सिनर्जिक बॉन्डिंग, राइट? कार्बनिल कौन सा दिखाता है? सिनर्जिक बॉन्डिंग दिखाता है. और वो क्या करता है? पाई बॉन्डिंग तो करता है, पाई बॉन्डिंग में डोनेट करता है सिग्मा एक्सेप्टर. कैसा होता है? सिग्मा एक्सेप्टर होता है. तो ये वाला तुम्हारा जो है ये गलत है, राइट? ए करेक्ट है बट आर इज नॉट करेक्ट. अगर यहाँ पे पाई एक्सेप्टर लिखा होता तो दोनों स्टेटमेंट सही हो जाते और वो उसका एक्सप्लेनेशन भी हो जाता, राइट? ओके, पर यहाँ पे ये सही नहीं है. आर इज रॉन्ग. कैसे हम लोग देखेंगे यहाँ पे? अगर हमको थोड़ा सिनर्जिक बॉन्डिंग के बारे में समझना है, इफ यू टॉक अबाउट सिनर्जिक बॉन्डिंग, दिस इज योर कार्बनिल ग्रुप, CO ग्रुप, राइट? हाँ, इट्स ओके, नो इश्यूज. वो थोड़ा देखने में थोड़ा गलती हो जाता है, नो इश्यूज. तो यहाँ पे क्या है? सिग्मा बॉन्डिंग हो रहा है. हम लोग देख रहे हैं कि यहाँ पे सिग्मा बॉन्डिंग हो रहा है. यहाँ से क्या हो रहा है? सिग्मा बॉन्डिंग में ये इलेक्ट्रॉन यहाँ पे दे रहा है, राइट? इनका यहाँ पे बॉन्डिंग हो रहा है. फिर क्या होता है? इसका जो पाई स्टार, जो एंटी बॉन्डिंग ऑर्बिटल होता है, एंटी बॉन्डिंग ऑर्बिटल होता है, वो ये मेटल के करीब होता है और यहां से यहां तक क्या होता है? इलेक्ट्रॉन देता है. मेटल यहां से यहां तक इलेक्ट्रॉन देता है, एंड दैट्स व्हाई दिस इज योर एंटी बॉन्डिंग ऑर्बिटल में वो एक्सेप्ट करता है. इसीलिए ये जो होता है ये पाई एक्सेप्टर होता है. क्या होता है? ये पाई एक्सेप्टर होता है. ओके, दैट्स व्हाई. ओके, तो यहाँ में यहाँ क्या हो गया? पाई एक्सेप्टर है, इसीलिए दैट इज गोइंग टू बी योर करेक्ट आंसर. ठीक है, तो यहाँ पे हम लोग इसको खत्म करते हैं. अगला हम लोग नेक्स्ट क्लास में देखेंगे। अंटिल देन यहाँ तक प्रिपेयर करो अच्छे से। ओके, सो अंटिल देन सी यू चिल्ड्रन, टेक केयर एंड बाय बाय।